At 9 minutes past 4 in the morning, a file went out. It was smaller than a photo on your phone. 80 minutes later, 8.5 million computers were dead. Not slow, dead. Start with one of them. A check-in desk, a hospital ward, maybe the laptop on your own desk. The date is the 19th of July, 2024. The company is CrowdStrike. It sells security software called Falcon. Falcon sits inside Windows, watching everything the machine does. To do that job, it runs in kernel mode. Kernel mode means it has the same privileges as Windows itself. When it is wrong, Windows does not survive it. That morning, it received a small configuration file, not a program, a settings file, channel file 291. The machine read it, tried to follow it, and blue-screened. Then it rebooted and blue-screened again. The security software that exists to keep the machine running is the reason it will not start. That is a fire alarm that was supposed to stop a fire, but instead ignites and puts the house out by burning it down. And only one number in that file was wrong. It was not a big number. Here is the number, 21. The template that describes this kind of file defines 21 input fields. The sensor code supplied 20. For a long time, that gap did not matter because nothing ever used the 21st field. On the 19th of July, 2 new instances went out. One of them put a real condition on field 21, so the sensor went looking for a 21st input in a list that only ever had 20. You have set a table for 21 and put out 20 chairs. Nobody notices until everybody sits down. Reading past the end of a list is one of the oldest mistakes in software. The defense is one line. Check the size first. That check was not there. And the validator, the tool whose entire job is catching exactly this, had a logic error. There were 2 independent safety nets, and the same file walked through both. Now the clock. The bad file was published at 4:09 in the morning, UTC. A corrected version was live at 5:27, 78 minutes. By software standards, that is fast. Most companies would call that a good day. And it did not save a single machine that had already taken the file, because the machine that could have downloaded the fix was already lying on the floor, beeping in blue. It could not boot. It could not reach the internet. It could not be told anything. You are shouting the correction at somebody who already cannot hear. In 78 minutes, the file reached airports, hospitals, banks, and broadcasters on every continent. Airlines stopped. Emergency lines were disrupted. Television stations went dark mid-broadcast. The window was small. The blast radius was not. This is the part everyone misses. The rollback path ran through the thing that was broken. Every automatic update system assumes one thing. If we get it wrong, we can push out a correction. That assumption only holds while the machine still works well enough to listen. Here, the failure disabled the receiver. So there was no remote fix. There was no reverse gear. The only cure was physical. Boot into safe mode, find the file, delete it by hand, restart. One machine at a time. Some organizations had tens of thousands of them. And many of those machines were encrypted, so you needed a recovery key to get in. For a lot of companies, those keys were stored on servers that were also down. It is like the spare key for your car was now locked inside the same car with your main key stuck in the keyhole. Big fleets took days, some took a week. Now put a price on it, because that is the number you will remember. One estimate puts direct losses to the Fortune 500 at $5.4 billion. That excludes Microsoft. Healthcare lost around $1.9 billion. Banking, $1.15 billion. Cyber insurance was expected to cover perhaps 10 to 20% of it. Delta Airlines canceled nearly 7,000 flights and processed over 176,000 refund requests. Its chief executive said the 5 days cost the airline $500 million. Now hold that number next to the cause. One configuration file and one field that was never there. Talk about just a small change with big impacts numbers, creating a situation with no way out. So whose fault is the bug? Wrong question. The bug is the least interesting thing here. Software has bugs. Every release process on Earth is built on that assumption. The job of a release process is to make sure a bug meets 100 machines before it meets 1 million. That is what a staged rollout is. A small ring first. Watch it. Then the next ring. Then everyone. This file did not get one. It went to every customer at once. And here is why. Internally, this was rapid response content. Small configuration files, updated many times a day. That class of update went through less rigorous testing than a full sensor release because it was considered low risk. But it was not low risk. It ran in kernel mode with the same privileges as the code that got the full process. The risk was classified by what the file was, not by what the file could touch. It is a mini, harmless-looking parcel, so security waves it past the loading bay and straight into the operating theater. Every organization you have ever worked in has a category like this. The change that skips the review because of its size. I have watched this exact mistake from the inside. I was working with an ice cream maker client on their tub filling process. They had a machine that filled a tub of ice cream automatically with the worker scraping off the end. Every time the worker scraped, one drop of ice cream would always leak out the side and rest on the plastic cover. Nobody thought much about it, since it was just a drop and naturally a common occurrence. Until we studied the downstream impacts of this drop. Some lids did not seal perfectly, and the ice cream melted and attracted insects in the transportation phases. Cartons of ice cream infected because of this small drop. We added a drop cleaning step, and the occurrences went from 20% to near zero. Invisible drop, significant damages. So take this to your own machine and to whatever you run at work. Look at what you have daily that may seem small and insignificant. It could be an Excel formula, a particular code setup, or even just a number that you replied to when checking out an order. That magical accidental change from 1 to 2 changes everything down the line. A good system will always create a safeguard that protects such mistakes from propagating downwards into a death spiral. So ask 2 things about anything you ship. How many people get it at once, and can you get back? 5 parts, and you can hold all of them at once. 1 field that was never supplied. 2 safety nets that both missed it. 1 release path with no staged rollout. 1 recovery route that ran through the dead machine. And 1 risk label attached to the size of the file instead of the read to the file. One last thing. This failure crossed the planet in 78 minutes. Next time, the opposite problem. An industry with effectively unlimited money that still cannot get 1 piece of equipment for 5 years. The richest companies on Earth, stopped by a vote in a small town hall. Speed is easy to buy. Some things you simply have to wait for. If you want to get better at how work actually works, subscribe. 1 teardown a week. That teardown is on your screen right now.